We had sold him 288 pieces.
Oh,
okay,
yeah.
cool, perfect. Yeah, but he didn't actually get 288.
Oh, so that's what happened.
Exactly, yeah.
Alzo's there. David and Amy are probably running late.
You were the freaking Kyle Setters will actually need this. We're, I mean, we'll learn stuff, but there's some over there that.
Just gonna wait a couple minutes to let everybody get on.
Yeah, it's pretty quiet.
I muted everybody.
Oh, you're
There
gonna
was
do.
There's
you'll
a
do-
lot of background chat going on.
Sorry, you'll do some introduction then, I
Yes,
guess.
I'm going to do the introduction.
Okay.
I just have 2 more people asking for the link, so I'm just sending it along. Um,
Yeah, it's really quiet when you mute it, eh?
It is.
It's like, is anyone out there?
Anybody?
I was just going to say, Bob, you should tell a story
Yeah.
just to fill the airtime.
Okay, I will get this started as people are coming on. I just wanted to let everyone know this is being recorded and will be posted to our YouTube channel if you need to look back and reference it. We'd like to welcome everybody and thank you for taking the time to attend our latest Tile Tech Talk. We are very excited to have Bob Weins and Maria Rudman of Schluter Systems to explain to us proper methodology of steam showers. Bob Weins has been with Schluter Systems for over 23 years. He's affectionately known as Uncle Bob by the team due to his extensive experience and knowledge in all aspects of construction. Bob has been heavily involved with building officials and consultants along the way to providing solutions for unique job site conditions. Continuous steam rooms require a specific understanding, and Bob's vast experience of steam room design and potential complications of not doing it the right way ensures a presentation worth attending. Maria will be in the background doing the Q&A moderator. She will answer any quick questions you have during the presentation, and we'll also bring up more discussion questions at the end. Please add your questions to the chat bar at any time. If you require a certificate for self-reporting CEU, please send me your full name and I will send that certificate along to you. If everyone could stay on mute while Bob's presenting, it would be appreciated. Take it away, Bob.
We'll do that. Good morning, everyone, and afternoon, I guess, depending on which part of the country you're from. Thanks for the introduction there, Lisa. Yeah, as she mentioned, I'm a commercial projects manager for Schluter Systems for BC. I've been with Schluter 23 years. I'm a carpenter on the other 22 years of my life. So I come in this from a construction background. Today we're going to talk about continuous use steam rooms and even residential to a certain degree. A lot of these practices apply. So it's really important that we understand the standards and best practices, and hopefully I can instill some of that information to you so you'll feel more comfortable specifying and constructing steam rooms. So without further ado, I'll go ahead here. Just a slight overview, a little overview. We're going to talk about terminology. It's very, very important. vapor drive, which is a key component of steam rooms and how they perform and the destructive condition that it can provide. The standards referring to the Terrazzo Tile and Marble Association of Canada. And that I'm going to use the acronym of TTMAC and 093,000 as I go through the presentation, just to make it a little bit easier on me. I'll go over some planning as well, and then design what kind of materials should be utilized, what shouldn't be utilized. So hopefully you'll get some insight into some of the do's and don'ts. Being in the industry for about 23 years so far, I've seen a lot of not so good, and I've seen a lot of good. So hopefully this will give you the information you need to do the right presentation or the right installation. So when we talk about terminology, there's steam rooms and steam showers. Now, steam rooms apply to commercial applications, continuous use. So that could be spas, fitness centers, something that's taking a lot of abuse, a lot of stress. So it's very important that we detail these appropriately. These steam rooms get utilized from anywhere from 12 hours to 24 hours. There's, steam rooms up at Whistler, such as Scandinave Spa, which is on constantly from first thing in the morning to last thing in the day. That thing's pumping out steam and creates a whole bunch of issues if not constructed appropriately in the appropriate materials utilized. When it comes to residential steam showers, and showers being the term, that's intermittent use, maybe used 20 to 30 minutes a day. And that could be periodically, maybe a couple times during the week. Sometimes the usage is quite extensive when they're first installed because it's a novelty, and later down the road, a couple of years, maybe once a week. So they're not subjected to the same kind of abuse. Some of the membranes that we'll talk about can be utilized in residential applications where they definitely cannot be used in a continuous use or in a commercial steam room. If we talk about the moisture has two different states, liquid and vapor or gas vapor. So when we take that liquid and we heat it up and it turns into vapor, it becomes very problematic. And that's really what I want to talk about or explain as we go through this, and the importance of designing a steam room to limit any potential problems with that vapor. So explaining what vapor is, a water molecules or a water droplet is made up of molecules. Those water molecules like each other, they gather, they make bigger droplets, easier to stop from penetrating through into the substrate. When we talk about vapor is a water molecule that's increased in size by about 1,700 times in its volume. And so you get this excitable, these excitable particles that are separating from one another. So they don't like each other as much as water molecules do. So they separate from one another. And as they separate from one another, the space that's free in between is a gas. And that gas pressurizes and forces that vapor through. So it's an extreme amount of pressure. I didn't realize this until I started doing some investigation for this presentation. The amount of pressure that develops when water goes into a gas state, and those molecules, how volatile they can be when they're forcing their way through the substrate. And that pressure also applies when it comes to the door going into the steam room. Having a door that swings both directions is a safe option, or at the very least, having a door that swings out. Having a door swinging in, and most of you probably know this, but having a door that's closing towards the inside, that pressure that I'm talking about can be very, very problematic. And you might not even get the door open. So there's a safety aspect to it too as well. So just keeping that in mind. So when we're talking about waterproof membranes, so we want to be able to treat the substrate so that we don't have to worry about harmful vapors getting through into the substrate and behind. So we put a membrane over top of it, and there's different types of membranes. There's vapor permeable membranes, which tend to allow, they would be fine for waterproofing, they would be fine for a residential application. But when we get into steam applications in commercial applications, a vapor retarder is required. The idea is to limit any of the harmful vapors from getting through into the substrate. So I've kind of talked about that whole thing about that water changing into a gas, which is a vapor, and finding its way through a substrate. Well, if that vapor passes through and hits a cold object, it recondenses, or a cold mass, it recondenses and turns back into water. And that's where the problem falls in, and I'll explain that as I go through. So when I'm talking about vapor drive is a condition where, much like what I was talking about, where you've got a water droplet, it's being heated and turns into that gas, into vapor, and we get a point of equilibrium. Mother Nature always likes to have everything equal. So a wet, humid environment will always try and make its way to a dry environment. And if those were equal, it would be fine, but typically they're not. That other environment that it's passing through into, if it's a colder environment, that's where the problem comes into play. So this is just an example of an install. We're not showing a vapor barrier going in behind the backer. We're just showing this condition developing in a steam room application and what the consequences are. So here we've got the water, it's being heated, it's turning into a gas, which is the vapor. That vapor is creating that pressure. It's hitting the cold object. The cold object is the tiled wall. Once it hits that tiled wall, because it's cooler, it's going to turn back into water. You get those water droplets on the surface. Once that tile heats up, the vapor forms again. When that vapor forms, creates that pressure, and it goes through sequences as it passes through the different elements. This could be the bond coat. This could be the backer, the cement. Yeah. Somebody needs to be muted, I guess. The cement backer, that's behind that. And it's going in, it's saturating that cement backer. Again, heating, turning into a vapor, and passing through, and then getting into the building structure. That could be insulation, etc. So as it's passing through all these different elements, it's going from a liquid state to a vapor state, from a liquid state to a vapor state. And so that shows the importance of insulating a wall, having a membrane in place that's not going to allow any of this harmful vapor to pass through. And when I say harmful vapor, that's because when we're talking about vapor, we can't stop it. There's nothing that will stop that vapor from passing through. So what we're trying to do is limit the harmful vapor from passing through. The only thing that will stop vapor drive would be metal or glass. Other than that, everything else allows it to pass through. This is a good example of what happens. This was an install that Maria and I visited, and we're doing a site visit on, and Maria being our architectural manager. And it had been installed for a number of years. This was the wall on the office workstation area in a condominium project. And so they had a waterproofing membrane that they had put on the wall. They had a CVU or concrete board that was placed over top of that as the backer. And then we're seeing the vapor barrier. So the vapor drive has pushed through the selected membrane that was installed, gone into the concrete board, saturated the concrete board, and made its way through all those different paths and ended up hitting the vapor barrier and behind. Now, having that plastic there, that 6 or 8 mil poly behind it, has stopped that moisture from getting in any further, but there's no way for it to get out either. So it just collects, creates mold. You can see the one picture in the middle there. It's got the bottom plate that is all rusted out. This is not good for anyone, This is not, the next time we have a project, nobody's going to put a steam room in if they have to deal with these types of conditions. It can be very, very expensive as well. So we've kind of broached the subject of that moisture and moisture management. It can be both liquid and vapor. So the idea is we know that the tile, the thin set, the caulking, the grout, sorry, all of those things aren't going to stop that vapor from passing through. So what we want to do is treat the substrate so that even though we know that's getting in there, it can evacuate efficiently without damaging the substrate that's in behind, the backer that's in behind, whatever membrane that's in behind. We want to have a system whereby through vapor equalization, it can dry out in between cycles by putting a very thin layer onto the waterproofing membrane. So there are standards in place, and those standards are developed by the TTMAC, the 093,000, and I'm going to go through a couple of those right now just to give you some insight into what the Terrazzo Tile and Marble Association of Canada can provide for you in terms of education, specifications, and furthermore. So the TTMAC handbook has all those requirements in it. I mean, when we talk to the tile setters, we tell them this is the tile setter's Bible. It really gives them all the information they need to put things together. And if it's something beyond that, then you've got multiples of manufacturers, representatives that have more than enough education to help you along the line, to be able to help you with those specifications, with the design, etc. So TTMAC has specifics on substrate requirements, membranes and drain requirements. So if it's a clamping drain, if it's a drain with an integrated bonding flange, all of those requirements are in place. The tile, the materials that you use for those installations, are they susceptible to moisture? Do they have a lot of porosity in them? It will inform you with those types of things too as well. And then it also refers to local building codes, accessibility requirements, door swings, manufacturer specifications. Whenever there's a specification or a detail in the 093,000, it'll refer to manufacturer specifications if it's something over and above what the 093,000 calls out for. So this is a detail for a load-bearing bonded surface waterproofing. So a membrane that's being installed directly over top of the backer board, over top of the mortar bed, and with a drain with an integrated bonding flange. So this is a detail in the 093,000 with the integrated bonding flange. That's allowing you to tie the waterproofing via bonding to the flange itself, and just having the concern of the drain grate itself, bringing that up to the height of the tile. But you don't have a lot of mass there or medium there where it can get contaminated. So it's a very appropriate application or suggestion. There's another detail for a clamping drain. So traditional two-stage drain, there are details for it. Again, suitable even for a surface waterproofing. Just the detail to tie into that drain because of the clamping mechanism can be pretty problematic, or it's just a lot of work for the installer. So having a drain with an integrated bonding flange can sometimes be much more advantageous, less labor doing the install, where this, you have to have a lot of skill to be able to follow these requirements. Most manufacturers will have within their specifications or within their documentation how to tie into a traditional clamping drain. Also, when we're talking about these membranes, the membranes have certain requirements. You have membranes that are permeable, as I was saying before, which are considered to have a perm of less than 1, but greater than 5. That could be used for a waterproofing membrane. That could be used for a residential steam shower. but not for a commercial or continuous use application. For that, we're looking for a membrane that has a 0.5 or less perm rating, meaning it is a vapor retarder. If there is a specifier, you're working with the material that doesn't provide that 0.5 or less, even with multiple coats of, let's say, a liquid applied material, then another vapor barrier should be installed, much like the picture I showed you at the beginning. That should be installed in behind that. But as you can see, that doesn't necessarily perform as well as one might want. So when we get into membranes, there's different types. I mean, there's sheet applied or gauge materials. There's liquid applied, and liquid applied sometimes require multiple coats. So you might require 1, 2, 3 coats, depending on the manufacturer. So it's really, really imperative that you get to your manufacturer, talk to them or the rep, and find out what's required in these type of applications. These all fall under a bonded waterproof membrane or load-bearing bonded waterproof membrane standard, which is ANSI 118.10. There's a new standard in place that is actually going to be attached to this. Before, there was no differentiation between something that was required for a steam room, other than it said that it needed to be less than 0.5 perm rating. The new standard will actually have ANSI 118.10 S for sheet and L, which applies to trowel applied as well, beside it. And when it comes to steam room requirements, meaning that it needs to be 0.5 or less, it's going to have an SV or an LV attached to that material. So you will know if it can be used in a steam room application, if that manufacturer warrants or recommends it for a steam room application. If it is, then if it had an SV attached to it or an LV attached to it, that required multiple layers, well, they would have to put that in their documentation. This is a new standard that's just come out. I think it'll be quite of an advantage for for recommending, for specifying, for design side of things, even for contractors. I think it'll really shed some light on what you're dealing with and how to perform with that product. As mentioned before, not all waterproofing membranes are vapor retarders, so just be careful with that. When we test for the standard of ANSI 118.10, they test for waterproofness. But now, with those extra additions or extensions to the language, you'll be able to know if they tested for vapor permanence with it as well, because the standard alone does not. So it's important to be cognizant of that and aware of that. And again, spelled out from the 093,000. So from the industry has said, hey, you need to be cognizant of this and make sure if you're using that for a steam room, that the manufacturer will warrant that and it's acceptable. So here we're going to show you a couple more details for steam rooms. So steam rooms can be applied, the application or the structure can be applied over concrete. It could go over cinder block. With that, you would have bond coat for your tile and a mortar bed. And the reason that we show mortar bed is because a manufactured product, such as a foam product with pre-slope in it, is not acceptable in a steam room. Residential steam shower, no problem. But in a steam room, it's mortar bed or concrete or nothing. And again, obviously, slope on that floor, etc. When it comes to frame construction, you would have a CBU that would be located, or a cementitious backer unit. Again, details from the 093,000 directed to that with that mortar bed application as well. If the CBU is being utilized, cementitious backer unit, then there is a requirement for a fiber tape going over top of the joints with thin set typically, and alkaline resistant screws would be another requirement, something that's not going to rust from not only from the surface, but from the concrete itself can be susceptible to damaging inappropriate fasteners. Plywood should never be used in a steam room. I don't know how many times I get it where the guys go, yeah, I've got the walls all plywood, it's nice and sturdy. What do I do now? Put something else over top of it, a foam board, something other than the plywood itself, because it's dimensionally unstable. As it heats, it will expand, and that creates problems. Same thing with gypsum-based products. Gypsum-based products aren't acceptable either. Even fiberglass gypsum products are not acceptable in steam rooms. Residentially, that's a whole nother ball game. But for commercial applications, continuous use, not acceptable. So I had mentioned before, there's bonded systems. They integrate over top of the backer. Tiles are set directly over top of it. A drain with an integrated bonding flange, a gauge material. So there are these solutions for that. Insulation comes into play too as well. It's all about heat loss to a certain degree. So insulating those walls, reducing that dew point, creating a warmer environment so that the damage isn't as extensive if that harmful vapor were to get through. And you can see here they're insulating the ceiling, and the ceiling is just as important as the walls for that matter. Slope is another thing, slope in the ceiling. So when we're going through design, we need to look at it and go, if I do multiple tiers of seats, is my ceiling going to be too low if I'm trying to go within industry standards, and that's 2 inch per foot is the slope that I want on that ceiling. And that's for the comfort of the user. Nobody wants those water droplets falling down on their head, or on their body for that matter. So the idea is to slope the ceiling so those water droplets will continuously move to the back wall, dribble down, and it doesn't affect anybody. Having slope on the floor is another thing. Slope to drain is important. I've been in steam rooms, I'm not going to mention where there's a puddle of water on the floor because the steam's coming in. The steam jets are where your feet are, so it's burning your feet, and there's no slope to floor, so there's a puddle of water of half an inch of water on that floor. So again, not something you want to be seeing. And having those seats being sloped to the drain too as well. We never want to have negative slope for something like that. Lighting protrusions or penetrations are another consideration. Every manufacturer has details specific to, or should have details specific to those protrusions and how to treat them. From lighting, which can be really problematic, to sprinkler heads. And these are some of the details that are available. Nobody wants to see what's up there on the right-hand side where that becomes the weak point in the insulation. The vapor gets through there, penetrates, gets up into the plenum behind, and we all know that, a lot of times that plenum that's up above is a lot of open space. It's a lot cooler. So your vapor gets up there, and I'll show some other pictures alluding to that, but the vapor gets up there, recondenses, turns back into water, and it might not even be destroying the getting to the substrate because having a vapor barrier there, but the screws rust out and then things start to fall apart. So just these details are some of the most important things you can have in an installation. The other is the steam pipe, where it's traveling through, having details specific to that. That steam pipe gets to a really high temperature. So having a material, a sealant around that pipe that can handle that temperature, I think steam pipes typically around 300 degrees Fahrenheit. You need to utilize something that's going to be able to withstand that and greater. So I strongly suggest using a sealant or a caulking material that is specified for that type of an application, not just a silicone or a polyurethane, because again, you get that weak point and it becomes very, very problematic. Utilizing materials that are acceptable within that environment. Stone tile in a commercial application, maybe not the best solution. A lot of porosity, a lot of capillaries within that. Those are very small tiles. I've been in steam rooms where the tiles just started dropping off the mesh in behind because there was no coverage whatsoever to grab onto those little tiles, which were at most a quarter of an inch at the foot of the tile because it was pyramid shaped. Translucent glass tile in a steam room. I know it looks sexy, but not the best thing in the world to be utilizing in a steam room. A paper face material is much better where you're peeling the front, but the back is completely clear of any glues, of any bond breakers, where the thin set can actually attach to those tiles. It's not attaching to a mesh. Down below, we've got a mosaic with a mesh. That mesh could be adhered with a water-soluble glue. All goes in well, but once it starts being subjected to certain conditions, it falls apart because that water-soluble glue lets go. The upper right-hand corner there, you'll see the image of the mosaics with the rubber mount in between. Those are very, very successful because we get great adhesion to the back of it. And then again, down below, you're seeing a paper mesh mosaic. And don't laugh. I've seen this before where you go in there and you start flicking the tiles off and you've got paper underneath it. Not a good thing to put in any type of wet area. It shouldn't even go into a residential application. That's good for a kitchen backsplash maybe, and that's about it, or a feature wall. When we talk about, I've been talking about mosaics here, but when we go into these larger format materials, it's always a good practice to back butter. I'll explain a little bit further, but back butter, getting the manufacturing film off the back of those tiles, burning the thin set in the back of the tile. When we go into wet areas and when we go into steam rooms, we need to have 95 to 100% coverage on the back of those tiles. The reason for that is we don't want any of that moisture to collect in behind and create all kinds of problems through vaporization, having efflorescence and all those types of things. So best practices, and this goes by what the NERA 093,000 says too as well, is back buttering the material and getting that 95 to 100% coverage. So here's the process of back buttering, keying in the thin set to the back of those tiles, taking off any of that bond breaker, that film from either manufacturing or dust, notching your mortar notches in one direction, dropping the tile down and working it in the opposite direction of those notches. That's pushing the air out. That's knocking down those notches so there's no voids for water to sit into. Or even some will use what we call a zipper lock. That zipper lock is combing the notches both in the same direction and taking them, collapsing them into one another, working the side to side, pushing out all the air and ensuring excellent coverage. Always a good thing for the installers to every once in a while pop one off, or if you're a site super, make them pop a tile off and see what kind of coverage you have. There's many times where I've gone and guys have said that, oh yeah, we back buttered everything, and then you have to go back and you've got a problem and you open it up and it's awful, and I'll show some images of that too as well. The other thing is utilizing mortars that are intended for large format tile, thixotropic thin sets that are designed for large and heavy tile. We're seeing so much of that now, so just making sure that we're utilizing the proper bonding materials for that. Spot bonding is not acceptable. It's easy for the installer because he doesn't have any lippage. He can take his tile, put it down on top of these spot bonds, level the tile out, looks good on the surface, but you have no coverage underneath. So in a wet area, in a floor area, in any area, this is not a recognized method of installation. Through the 093,000, through industry practices, this is not a good way to be doing installs. And again, you might laugh, but we see this time and time again. And this is what I was talking about on coverage. These were some seats in a spa that we had to do some work on. It was 3 years old, and they had to pull it apart because a lot of details were missed. And to go back in and redo this steam room was about 130, 140 grand. So nobody wants to incur those costs. Nobody wants that reputation of doing an inferior installation. On the left, you see the conditions of what we would consider to be efflorescence. Efflorescence is that moisture is getting in there, it's heating up, it's coming out in the form of vapor, it's pulling out the byproducts of the Portland cement that's mixed with the thin set, because all thin sets, all all grouts have Portland cement in them. So it's pulling those byproducts out and depositing it on the surface. You can see in the top right where we've got a discoloration of a profile. And I'll talk about that a little bit more, but that's due to efflorescence again, etching the profile itself, an anodized material that was utilized in a steam room. Even body oils, someone sitting on the seat itself, stepping up onto it, can be problematic with anodized materials being in a steam room application. We need to use more robust materials. The other thing that we need to look at is in the 093,000, it calls out 301 MJ, which is movement joint detail. It says that, every change in plane requires a movement joint. So wall to wall, ceiling to wall, floor to wall, those should all be soft zones. They should not be hard grouted. We need to leave room for expansion. We can do that by way of a caulking, a sealant that is matching, or we can use a prefabricated movement joint for that part of it too. Benefit of the prefabricated movement joint goes in with the installation. You never have to remove it again. So there are some benefits to going to the prefabricated route. This is kind of the issues that you can have with an applied sealant on site. One is the mold that develops over time. Especially with vapor, it gets in behind, creates that mold, creates a problem. Not so much. I can go in there and I can replace it. But what happens, and we had that happen in Calgary, where they went in to replace that sealant, they knifed it out, the maintenance guys, cut right through into the material that was in behind, the membrane, therefore creating a penetration, therefore causing the steam room to fail. So yes, it can be applied, but it can be problematic too as well. So here I've got just kind of grout selection is another thing, that we should be looking at. Cementitious grouts are great products. They're easy to work with, but they have a lot of porosity to them. They can stain. There's more maintenance involved, like sometimes removing that grout and replacing it. Sometimes sealers are required too as well. There's various glass bead technologies that tend to be a little bit more robust. Haven't looked into those ones. Epoxy grout is probably the most advantageous, the most specified, recommended in a steam room application. Harder to apply. They are moisture resistant, not going to stop the vapor from passing through, but they don't stain. That's the purpose of them. A little bit more robust, where if I go to a cementitious space, if I'm putting that sealer on it, sealers have a lot of porosity to them too as well. They're meant to stop staining. They're not meant to stop moisture penetration. So with an epoxy grout, I don't have that problem. Polyurethanes, and I didn't know this myself, but when I looked into it, polyurethane grouts, none of the manufacturers recommend polyurethane grouts in steam rooms. And if someone out there in manufacturer land has a different product, they could let me know. But as far as I know, I went to all the different websites and found that none of them would recommend their polyurethane grouts for steam room applications. And I think that's all to do with the volatility, the amount of stress that they're under in a steam room application. Next area I like to talk to is about planning. And, I am going through this quite a bit. I'm throwing quite a bit of information at you. But the idea is to give you some insight into what you can do to alleviate a lot of these problems as you're working through your designs, etc. Or even if you're out there doing an installation and what's important and what's not. So utilizing a proper bonded membrane, number one, the picture on the left there, dealing with any of those penetrations, making sure that no vapor is going to get into those penetrations, creating all kinds of problems. The insufficient thin set coverage I was talking about. So again, showing images of efflorescence. It could be latex leaching. It could even be a material that was put underneath a large format tile that didn't have the chance to cure properly, and it's re-emulsifying and coming out. There's a whole bunch of different issues that can develop when we don't follow what manufacturers say with their installation processes. And when we're talking about mortars, temperatures can be a problem with mortars. Drying times can be a problem with mortars. So we just need to make sure we're cognizant of that when we're specifying, when we're on site and we want it fast tracked. There can be a lot of issues that can be alleviated with a little bit of attention to the install. And that goes for leaving some budget in there too for these types of things and time frame. These are conditions of what I've seen out in the field where I don't believe those details were taken into account. The one on the right was an installation in Vancouver where we were involved in the shower application of the installation, but the contractor had his idea of what he wanted to do in the steam room. This is about 3 to 4 years old, wood frame. They insulate, spray insulation in the studs, wood frame on the seats. But in a very short period of time, the way this developed was the tiles on the changing room side started falling off the walls. That's because the moisture had gotten in and expanded the wood frame construction. And this could apply to metal frame too as well. But in this particular application, it expanded the wood frame material, which pushed the tiles off the wall on the opposite side. When we went in there and looked at some of the elements prior to remediating the installation, I could grab onto a hose bib, which would be for maintenance purposes, and I could move it around, shake it around without any impedance. I could move the steam pipe around in the wall without any impedance, meaning that they didn't detail those. There were other issues too as well. The one on the top right was an install that I had gone and taken a look at, and this is referring to what I was talking about, whereby the detail for the sprinkler head wasn't detailed properly. The lighting wasn't detailed properly. The thermostat probe wasn't detailed properly. And so the moisture got up into the plenum up above. There was a cold air return up there. That vapor recondensed, turned back into water, fell down on the structure up above, rusted out the screws, and the whole thing came down. Well, didn't come down. It sagged in the center. The only thing that was holding it up, and I've seen this a few times, where the tile on the exterior walls, because the ceiling was installed first, was the only thing that was holding that ceiling up. So a little bit of yanking on it and the whole thing comes down on you. And then back to those other images I showed you before, because we can do all kinds of things appropriately. But the biggest is to deal with that membrane, deal with those penetrations. We never want to see this condition that we see in all of these pictures. It doesn't look good for anybody. It's not good for the installer. It's not good for the developer, the GC, the architect, the designer, the owner. Doesn't make any difference. And going back in and repairing it afterwards, everybody wonders what went wrong. So reputation is everything too as well. So, it's just not a good area to get into. So really important that we detail these things properly. I talked about lighting as well. The lighting is a big, big key. We see this time and time again where the light fixture isn't appropriate for the installation. We look at the one on the right, somebody did some research and installed a light that is not going to be problematic. At the very least, I've encouraged in the last little while that you build a box that is a vapor retarder up and behind the lighting, because they're LED now, they burn fairly cold. So you can get fairly close with that box, build a box in behind. That way you only have one low voltage wire coming through or a BX cable coming through. And if the light fixture ever fails, we remove it, replace it, but it hasn't gone into the structure and destroyed everything what's up and behind. Again, we see this time and time again. I was in Vegas at IBS, and they had I went around in the lighting area and walked around and said, hey, do you guys have rooms, lighting for steam rooms? No. Do you have lighting for steam rooms? No. Nobody has a solution. So it's upon us to look at and specify lighting applications that are not susceptible to these kinds of conditions. And the new technology we have now, we can do that. It just takes a little bit of research. One of the other things is having qualified installers, having an installer that has, 5 or more years of experience installing in steam rooms, not somebody that gives you the lowest price, because lowest bid isn't always the best thing. So taking that into account too as well, the experience that someone has, the reputation to do these types of things that the contractor has. Work environment is really important too as well. Quality control, looking at building codes, specifying the appropriate materials, the work environment, storage. Did that material get a chance to acclimate? Was it sitting in the back of the truck and we brought it in and installed it right away? Ambient temperatures and surface temperatures. When working with thin sets, we have to be considerate of that too as well. Curing times. Just because it was installed yesterday doesn't mean it can go into a working environment or being handed over to the owner to start operating within the next week. Sometimes we have to respect those curing times, and that goes for mortars and how they need to be mixed and all those types of things too as well. Having an integrated system is important. Using one manufacturer, having that integrated installation system, having a partner that has on-site technical support. They can come on site and they can tell you how to deal with certain situations. And specification assistance. So they have architectural managers who can come in on the specification side at the beginning. We'd much rather have that than having to have to go on site and there's a problem and having to have to deal with it after the fact. If we can get in there beforehand, design it as such, we're much further ahead. Everybody's much further ahead. Lastly is design. So on the design side, we can use different backer materials because we need something to go over top of, let's say, a framed application. That can be by way of a foam building panel, which, although it has a low vapor permanence, we would still strongly recommend, and this goes for any foam materials, they all require to have that vapor retarder go over top of them. That membrane that's 0.5 or less go over top of them. I don't believe there's any foam materials, backer materials, construction building panels that will be a standalone in a commercial steam room continuous use. They provide insulating, they're lightweight, dimensionally stable. That's something I talked about with plywood. And it can be flat, plumb, square, and level. We can utilize CBUs as well. CBUs have great strength. They're moisture resistant, not waterproof. So again, we have to go over top of this with something that is a membrane that has that 0.5 or less, and in some cases require a vapor barrier to go in behind it, depending on the solution of the material, whether it be a sheet applied or liquid applied, going over top of that backer. We need to make sure that we take all those details into consideration, talk to the manufacturer and what their requirements are. Technology allows us to go and take that old two-stage drain, which I showed how complicated it can be to tie into that with a surface waterproofing or a bonded waterproof membrane. There are adapters that we can adapt that two-stage drain and put a integrated bonding flange into that application and bring the surface waterproofing up to the surface where it should be, tying it in with the bonded system and changing the design to adapt. So we have pre-existing two-stage drain, we can adapt and bring it up to the integrated bonding flange, very simpler with an adapter drain type application. Line drains, linear drains, trench drains can be included within the application too as well. This gets a little bit complicated on the fact that, now the whole design of this is to be able to use a larger format tile. When we get into larger format tiles, we have to look at the DCOF, or the dynamic coefficient of friction. So again, be very cognizant of that. Just because I used a large tile outside of that wet area or that steam room application doesn't mean I can use it inside. And that goes for residential as well. When we look at residential applications, everybody wants curbless applications. If I take that tile that maybe might be in the non-wet area and put it into the wet area, there might be some slippage issues with that. So we just want to make sure that we have some anti-slip in that. Take into account, we already talked about insulation to a certain degree. This looks beautiful as far as having all these windows, but those windows, they will conduct the heat from that assembly. So what ends up happening, you're going to get condensation all over those windows. There's going to be high maintenance, and it beautifies, yes, but it can be the other considerations have to come into play with it as far as the maintenance. How do we tie into those windows? All of those types of things we have to think about. With that, as I've been saying, we've looked at variations in, whoops, we got to go back here. Sorry about that. We've looked at variations in lighting. I've seen a lot of indirect lighting lately. Well, how is that indirect lighting being powered? I've seen electricians come and punch through conduits, but that conduit makes a great big void. If we can simplify with a low voltage wire and detail that indirect lighting, whether it be through a ceiling application or under seat application, these are all things that we need to take a look at. Speakers in this type of an environment tend to be very popular. Making sure that that's not going to be problematic, building a box in behind those speakers, because I don't know any speakers that are going to stop vapor from passing through them. Where the plumbing fixtures come through, where the hose bib, as I was mentioning before, where the steam pipe comes through, we need to make sure we detail all those areas. And missing any one of those can be extremely problematic and result in a failure. Something very, very small. Not trying to scare you. I'm just trying to give you some insight into the things that I've seen in my experience where it becomes very, 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 very problematic. Steam nozzles. Where is the location of that steam nozzle? We should be anywhere from 16 to 18 inches off the ground. It should have a protection around the outside of it. I've seen it where we had one installation where it was a cinder block wall. There was a void up at the ceiling area, so that's where they punched the steam pipe out. And the steam nozzle was 6 inches from the ceiling and pointed at the ceiling. So within a 4 or 5 year period, that whole ceiling came down because it was not only not efficient, it was easy for the installers to do, but it created a huge problem. And then the steam room was down for almost a year because nobody was accepting responsibility. And then the users of that facility were quite upset because they had to wait a year for somebody to take the responsibility of the design. When we go into steam rooms, it's really, really important. And we look at the materials we're using too as well. I've already mentioned prefabricated movement joints, allowing for that movement. But when it comes to profiles, my experience lately has been I wouldn't do anything but stainless steel. And with stainless steel, I would probably go to the extra extent and go to the 316L. The 304, although robust, might not stand up as well, especially in a pool area, as the 316. So again, things to take into consideration. So quality control and cooperation are key on something like this. So you need to have your checklist that you would go through, looking at the different things, meeting with inspectors and meetings and having inspections. Being able to deal with the owner, sitting down with the architect, project manager. We do orientation meetings at the beginning of projects, so everybody's on the same page. It could be from the plumber to the electrician to find out how they're going to handle things so that we're not doing it later when it's all put together and there's a problem. Then how do we fix this thing? We want to be able to look at that at the beginning. Use your manufacturer reps. They have the education, the knowledge to be able to provide that for you. Use your architectural managers. They have that education. They'll be able to give you that information if you have a problem, and utilizing the TTMAC. And in some cases, some of the TTMAC's inspections. But the inspectors usually come in when there's a problem, not when it's at the beginning stages. So just keeping all these things in mind are very, very important. So kind of the key takeaways from this, if anything, is that you want to limit those protrusions or those penetrations. Make sure they're dealt with so you don't have any problems. utilize qualified, experienced contractors to do the installation so you don't have these problems. They're cognizant of it. They're not going to overlook something because they're in a hurry to get it done because they underbid the project. Make sure that you leave ample information for them or references to the different manufacturers within the specification or the design to be able to access that information. And again, I'm going to go back to this, but using an integrated approach to whatever you're doing. If you're using multiples of materials from different manufacturers, chances are there's not going to be a warranty in play. But if you concentrate on one manufacturer for one product or one system, then your manufacturer is obviously going to back you up if there is an issue. And that is my presentation. So hopefully you gained a little bit of information, and hopefully I didn't scare you too much. But I'll leave it at that. And if there's any questions, or if Lisa or Maria want to say anything, I will bail out.
Thank you, Bob, for all your information. If anyone wishes to unmute and ask a question to Bob directly, please feel free to do so now. Otherwise, a reminder, if you need the certificate for completion, just send me an email and I will get it done.
Bob, I have a question.
Yes.
Right from the very beginning, and that was an excellent presentation. I really liked. You were very thorough, so thank you for doing. I can see you did a lot of research there, so that's great. Thank you for that time. From the very beginning, on the very first slides, you mentioned about how the vapor penetrates right through, and the 6 mil or whatever poly actually holds back a lot of the moisture, but there's still the cavity that's actually absorbing the moisture. Do you have any suggestions or observations about, because usually these are behind walls, and so there is no air movement opportunities. Do you have anything to comment about that cavity space where, it could be interior or exterior walls?
You could send me an email, but what I have kind of looked at and have alluded to in the past is putting like a hat track over top of the studs, so those cavities can breathe back and forth.
Mm-hmm.
And we've looked at conditions where you vent top and bottom so that the air can move around in behind. I've even seen some companies or GCs come in and put some venting in as well within that cavity that's in behind to get some cross ventilation. I think the one that I showed you there with the wood frame and the sprayed in foam, they put the backer directly to that wall, and so each one of those cavities becomes its own little incubator and problem area. So by creating furring strips for your backer to go on so you can get some cross ventilation, might be an option available to you. The other thing is, first and foremost, is to use a membrane and to deal with all those possible penetrations at the very beginning, and to use a solution that's going to not allow that harmful stuff to get through. We know vapor is going to get in there, but if we can limit it with that 0.5 or less, those vapors that get in there aren't going to be problematic. The picture that I showed with the vapor barrier behind and with all the condensation on it, that was a membrane that probably shouldn't have been used in that application. The other one I was talking about, which was up at Whistler, was a situation where they kind of used a bit of this and a bit of that and didn't detail around the lights and didn't detail around the steam pipe and that type of thing. And when at one point they wanted to go in and try and do a retrofit, well, to me, that's like kind of like painting a pig. When it starts going, it's going. And at that point, you kind of got to tear it out and start over again. So I guess the biggest take on that would be to make sure that the membrane that you're using or the manufacturer that they're using is going to have that 0.5 or less, and then detailing and making sure those details are taken care of. And that should alleviate a lot of those problems. When done correctly, they're very successful. We just did 3 steam rooms at the YMCA Robert Lee downtown off of Burrard. And again, very, very detailed with the architect that was involved. They do a lot of steam rooms and multiple inspections for that matter. But if we can details with all those things, that we're so much further ahead.
Bob, can I intersect?
You sure can.
We have a really great question that from one of the participants. How do you properly waterproof a curved wall in a residential steam shower, which would also most likely be the same in a commercial continuous use steam shower?
Yeah, and so there are different applications. I mean, for us, I guess I can talk product a little bit now. We have a V board, which is a serrated board that you can use on organic walls. So you've got a backer that you can wrap to accommodate the curves in the wall, and then taking something like Kerdi and going over top of it. We're talking residential right now. Just taking regular Kerdi or a liquid applied material if you want to go that route. But with our materials, obviously, we want a system in place. So taking your Kerdi and going over top of those serrations, depending on which direction they're going, if they're opening up or closing up. Depends which side of the board you're using as far as that goes. And then detailing with a band and using a variant of serrated teeth cut into the banding to accommodate the curve in that wall, top and bottom. But if you need more information on that, we'd be happy to send that to you, or some images that we can provide for you of that. Maria?
Yes, I will put a note with your email so that people can, or that question can be relayed to you and you can offer a detail.
Sure.
Yeah, so that, other than, there was another question which you did reply to on, can foam panel boards be used in commercial steam rooms? I replied yes, as long as the manufacturer approves that specific use. Just like the grouts that you mentioned can't always be used in a commercial steam application.
Yeah, and even with the foam board, I don't know any foam board that you can just go ahead and use the foam board by itself. You have to apply a membrane that has that 0.5 or less over top of that foam board. The foam board's just a backer. It's an insulator. It's lightweight. It's easy to work with. It's dimensionally stable, but you still have to put something over top of it. I would never leave it as a standalone for a commercial steam room or a continuous use. And we do have experience with that. And so again, I would not recommend just having a foam board and having that as a standalone.
That's about it for questions on my end, Bob.
Okay. Well, to just mention, when we're talking about membranes, at least for our membranes anyways, our Kerdi DS membrane, which is recommended for steam rooms, is a 20 mil product. So our regular Kerdi is about an 8 mil. It's a 20 mil product, which has a perm of 0.19, so significantly less than that 0.5. So we're very, very confident when utilizing that particular material in steam room applications. And then we have specific details for penetrations, for lighting, for all of those things. So we're very experienced with it. So if you want to get with us, and we'll be able to help you out in that scenario.
Great. Thank you, everybody, for your time. Thanks, Bob and Maria, for all your info. And hopefully you'll join us next time.
Okay. Thank you. Thanks, everyone. Bye-bye.